Okay, so good morning, all of you. Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Okay, so now I'm going to share my screen. Let me know whether it is visible or not. Okay, is my screen visible?
Yes, ma'am.
Okay. Okay, so today we will be starting your this program with the first lecture, and in the lecture I will be discussing about basics of chromatography. As you have already taught the chromatography in your seventh semester, eighth semester, and as you have done your BPharm, uh, then you might be knowing many of the things about chromatography. But whenever I will be discussing anything, if you have some question or any doubt, you can ask me anytime. Okay. Okay. So let's start with this. Is the screen visible properly? Is my presentation moving?
Yes, ma'am.
Okay. Okay. So the first topic is about introduction to chromatographic analysis. Okay. As we are knowing that chromatography is basically a separation technique. Okay. First and foremost, use of chromatography is separation. Okay. But because of new advancement, sophistication in instrument which is used in chromatographic analysis, and we are getting the chromatogram through which we are able to qualitative as well as quantitative measurement in addition to separation. Okay, means initially the use of chromatography is for separation, but nowadays in newer and
Ma'am,
more, yes.
ma'am, your slide is not visible.
Okay, just a minute. Is it now?
Yes, ma'am.
Okay. Okay, so chromatography was initially used for separation, but due to advancement, sophistication in instruments, we are able to go for quantitative as well as qualitative analysis and identification, quantitative measurement through chromatography. Okay. We are knowing that there are number of methods which is there into chromatography. Different kind of chromatographies are there. Okay. So any kind of sample, whether it is in liquid form, solid form, gaseous form, or even the isomers and compounds with kind of similar kind of structure, we can separate those compounds, we can analyze them. So, okay, we can quantitatively measure them through the chromatography. Okay. Now, the most important thing in chromatography is the sample size. Okay. Even if your sample is very small, in very small quantity, even less than 1 microliter, we can analyze that sample and we can provide very insight of information. We can go with complex analysis with this also. Okay. In HPLC GC, we can measure up to 20-25 samples with simultaneously. Okay. Means you have all of you have operated UV, we can analyze 2 or 3 samples simultaneously. Even if we want to go with analysis of 3 samples simultaneously through UV, we have to go with complex method. We have to use complex methods in UV. But in HPLC, if we are optimizing our proper mobile phase, in that case, we can analyze 20 to 25 samples together. So that is the main advantage of chromatography, that we can analyze very complex mixture, we can separate them, and we can get the information about the components which is present into sample. Okay. In chromatography, once your sample is separated, it will be analyzed and it will be detected through detectors. Okay. Is the presentation is still visible? Because when I am going to enter some new student into the meeting, the presentation might not be visible. Is it visible?
Yes, ma'am.
Okay. So if mass spectrometry or infrared or NMR, we are using or we are coupling with chromatographic system, then that system will be called as tandem system. Okay, like LCMS, okay, LCNMR, LCIR. Then that kind of system will be called as tandem system. Okay, tandem mass spectrometry LCMS. Okay. Okay, now tandem systems. Why we need to couple this LC with mass spectrometry? Because this will be giving us advantage that even our sample is present in a nanogram size, means very small size sample is there. Then also we can properly analyze the sample. It will be separated and it will be characterized. So now moving ahead, that there are mainly two phases into any chromatography. Okay, phase means anything. A phase can be a liquid, solid, or gas. Okay, these phases will be interacting with each other in chemically or physically with the analytes which we need to separate. Okay. So mainly the two phases which is used in the chromatography, they are termed as a stationary phase and a mobile phase. Okay. As the name suggests about stationary phase, stationary means it will be up in a fixed place. Okay, so that's why we are calling it a stationary phase. While the mobile phase is a liquid or gas which will be moving ahead, okay, over or through a stationary phase. Okay, so it is a mobile phase. Two phases, stationary and mobile phases. Okay. Now, generally, analytes are introduced through mobile phase streams in the system, okay, like in GC or HPLC system, we will be inserting or introducing the sample with mobile phase generally, okay, and it will be moving ahead on the stationary phase. Like, but in the PLC or paper chromatography, we are not introducing the sample with mobile phase. More sophisticated systems nowadays, which is used, are using the introduction through mobile phase stream. Now, some of the analyte will be interacting with the fixed phase, means our stationary phase, and it will be retained on the mobile stationary phase. Okay. While some of the analytes which are not interacting with stationary phase, it will interact with mobile phase and it will be moving ahead with the mobile phase. Okay. Retain analytes which is retained on stationary phase, it will be moved further slightly or more with the fresh portion of mobile phase. Okay. Okay. So those ultimately the thing is those analytes or those components which is interacting more with stationary phase, it will be remaining there, and those analytes which are interacting with mobile phase, that will be moving further. Okay. So if your component is having more affinity, more solubility in the stationary phase, it will be moving less. While if it is having more affinity and more solubility, more towards the mobile phase, it will be moving further. Okay. To achieve the separation properly, each analytes is spending different length of time on the stationary phase. Okay, that's why we are able to separate different kind of analytes. Okay. Likewise, in this figure, is the figure visible?
Yes, ma'am.
Okay. So, as you can see in a figure, this figure, that is a column showed here. Okay. And we are introducing a sample mixture which is having components, two components A plus B, which is introduced in a packed column. When we are adding the mobile phase into this system, this packed column which is having sample, you can see in the next column, means the figure second number column is showing that A is moving more faster compared to B. Okay, and next columns, that A is further moving more compared to B. That means A is having less solidity or less affinity towards stationary phase, and it is having more affinity and more solidity towards mobile phase. That's why it is moving more compared to B. Okay. Now, once A has been crossed through the column, and when it is eluted, it will be reaching to the detector, and when it is reaching to the detector, we will be getting a response. Okay. In the down portion of that your this figure, you can see that the there is a chromatogram shown, which is a graph of detector signal versus time. Okay. Once A is reached to the detector, it will be giving a response, and afterwards B will be eluted on further addition of mobile phase, and it will be reaching to the detector. Okay, so we will be getting the response of both components A and B once it is eluted out from the column. Now we can we are having a example here, that if we are having two boats or three boats in river, and when these boats are moved on bank, when they are tied on bank, they are not moving in the downstream with the water, okay, of river. But when they are released from the bank of river, they will be moving down according to their weight or their affinity. Okay? When the boats are moved there, like in they are stick to the stationary phase, when we are releasing them, and means when they are with mobile phase, the boats will be start on the same point, but they will be reaching on different number at different point according to the final destination. It means likewise our components will be starting simultaneously, but they will be moving further according to their ability to move with mobile phones. Now, the history of chromatography. Okay. Now, how the chromatography started, how it come into existence. Okay. The first chromatographic separation was achieved, reported into 1903 by Tesvet, who separated plant pigments using stationary phase, which is made up of calcium carbonate, and he had used mobile phase of petroleum ether. Okay. Uh, Means we can say that almost about before 100 years this separation technique was started, but it has taken or it is being used very strongly nowadays, because even in different pharmacopoeias, if we see that many of the UV methods which was used for different kind of drug analysis, they have been replaced with chromatographic method. If you check with Indian Pharmacopoeia 1996, you will be able to know that some of the drugs which were analyzed with UV or potentiometry, they are now analyzed through HPLC or GC methods. Okay, so these methods, HPLC and other chromatographic method GC, they are used across many analysis of many drugs. Okay. Okay, so Tisvet had separated two plant pigments with the use of stationary phase calcium carbonate and mobile phase petroleum. Okay. He had analyzed that these two color pigments are separating through the column. Okay. One of the pigment was eluted and in different colors. Okay, so those pigments are having different color. Okay, so from that the name chromatography was given, um, like in chroma means color and graphene means writing. Okay, so from that the chromatography word color writing was come into existence. Then after that were different advancement. Likewise, on the in 1941, Martin and Swing has published a paper for describing the partition chromatography, okay, in which the stationary phase was high volume liquid, which was coated on solid support. Okay. Then after in 1952 they were they have received a Nobel Prize for the same. Then after in 1952, Martin and James has invented gas liquid chromatography. HPLC come into existence in early late 1960s. Okay. But initially the HPLC was not got much wide acceptance, but because of some reasons. But afterwards, instrumental components which was used was able to handle the pressure up to 6000 psi, and the pumps which can deliver the pressure in smooth manner. Then after the HPLC was further accepted more. Then after the development in HPLC was there, that HPLC was updated with UPLC, ultra performance liquid chromatography. HPLC can withstand the pressure of 6000 psi, while UPLC can withstand the pressure of 15,000 psi. Then after in 1990s, electrochromatography was developed. Okay. In this electrochromatography, the mobile phase is driven through electrical field rather than a pump, okay, which is flowing through a packed capillary column. We can summarize these landmarks in chromatography through this table, that in 1906 liquid solid chromatography, 1942 liquid can you can see here in 1970s, which is about UPLC, and 1952 gas liquid chromatography, and 1990s capillary electrochromatography come into existence. Now, if we want to describe a proper principle of chromatography, okay, in chromatography, generally the principle when we are going to write, we are considering the column chromatography. Okay, so in column chromatography, analytes are injected into mobile phase stream, okay, and that analyte will be swept onto column which is containing stationary phase. Now, not all the analytes which is introduced into stationary phase always interact with stationary phase. Some of them will not interact with stationary phase. They will be eluted first. They will be moving with the mobile phase only. Like when we are introducing sample into stationary phase, first of all, mobile phase will reach to the detector. Okay. But some of the analytes are such, they are not entering the stationary phase with the stationary phase at all. They will be eluted and they will be reaching to the detector. So they will not be retained by the stationary phase. Now some of the analytes are such, they are not interact. They will be interacting so strongly with stationary phase that they will remain on the column permanently and they will not be reaching to the detector. That will never to be seen again, means they will not be reaching to the detector. Now between those two extremities, like some of the analytes which is not retained by stationary phase, they will be reaching to the detector first, and some of the analytes which is not moving with mobile phase, which is interacting very strongly with stationary phase. Between those two extremities, some of the analytes are such which spend some time with stationary phase and it will be further moving with the mobile phase. Yeah. Between these two extremities, those analytes which is showing some partial interaction with stationary phase and mobile phase, we can separate them because they will be spending a different length of time in those two phases. Okay, so at the end of column, we can use out those components and we can uh, separate them and we can detect them. So, if we want to describe the principle in a very simple language, then we can say that those components which is having more solubility, affinity towards stationary phase, that will be remaining for more time in column, while those components which is having less solubility and less affinity towards the stationary phase, it will be moving faster way through mobile phase and they will be detected. Okay, so because of affinity of or ability of different analytes, we are able to separate out them. Okay, now stationary phase can be finely divided solid, which is spreaded as thin layer on sheet of glass or on plastic. Okay, many of you might have done PLC and paper chromatographic analysis. Have you done it? I think you have done at least TLC and paper chromatography in your B.Pharm section. Have you done it?
Yes, ma'am.
Okay. Okay. So in that we are using finely divided silica gel. Okay, and it will be spreaded as a slurry on glass sheet or on plastic. Even plastic can also be used. Even there are some TLC plates which is already made. TLC plates are available, so we can use them also in HPLC. Okay, the already prepared TLC plates are used. Okay, you will be showing if you might have shown those TLC plates, but if you have not, and then we will be showing you. Okay. Okay, so that can be a finely divided solid which is sprayed on the layer of glass sheet or plastic sheet. Okay. Or that can be a column which will be packed, tightly packed with finely divided solid. Okay. And that column can be made up of glass or even of stainless steel. Thirdly, the stationary phase can be finely divided solid, which is coated with thin layer of organic liquid. Okay? And afterwards, it will be packed into column. Okay? The difference between second and third one is that second one is having stationary phase in which solid is packed, while in third the column is packed with solid, but before the packing, the solid is being coated with thin layer of organic. Okay, so in second one, there can be a partition phenomena, because if you are using liquid as a mobile phase, there will be stationary phase and liquid of your mobile phase, so partition will be occurring for separation. Fourth kind of phase can be a glass or silica capillary, okay, not column, capillaries, which is having very small internal diameter. to be having a coated surface. Okay, means directly on capillary liquid, organic liquid will be coated. Okay? Now the difference between the third one and the fourth one is, in third one the liquid will be coated on finely solid and then after it will be packed in the column. While in fourth one the liquid will be directly coated on the capillary inner surface of capillary through some of the bonding or some of the interaction. So we will be having different kind of stationary phase. Now the mobile phase, which is moving, that can be a gas or single liquid solvent, or that can be a mixture of solvent. Okay? We generally mixture of solvents are used, but if your sample is not much complex, we can even achieve separation through use of single solvent also. Okay, because the components might be able to move in a different rate with the use of single solvent also. Now the modern instruments make use of columns. Okay, we are in the simple chromatographic methods only. We are using this TLC or paper chromatography, but the modern instruments generally use columns, HPLC and GC. They are using columns. Even it is also a sophisticated and modern instrument. We are using the TLC. Sample will be injected to the mobile phase and will be achieved, and we will be getting a signal which is plotted as detector signal versus time, and that plot will be called as chromatogram. Okay, you must be knowing that plot of detector signal versus time will be called as chromatogram. So the graph of detector signal versus time is chromatography. Okay, here in the figure here, you can see the chromatogram, which is the graph of detector signal versus time, retention time. Okay. We will be having responses of different components as they are eluting. Okay, retention time. The first eluting component will be having less retention time. Then after, as they are eluting further, they retention times. Okay. Okay. Now, in any of the chromatography, what result we are aiming at? Okay, what we want at. Okay. So, whenever we are going with chromatography, first of all the analytes which is present in the mixture, they should be separable. All the analytes need to be separated. Okay? Then after, secondly, they might be separated, but we should be separated peaks. Okay? Here in figure, you can see that first, second, third, fourth peaks, we are properly separable. Okay? Now, when you will be performing the practicals, you will be getting results that these two peaks, any of these two peaks will be merged with each other, and we are not getting well separated peaks. In that case, we need to make changes into our chromatography parameters. We may need to change our mobile phase composition, we need to change our wavelength, we might need to change the pH of mobile phase. Any chromatographic parameters we will be needing to change in case when we are not getting well separated peaks. Third thing which we have to achieve through chromatographic separation, that the peaks need to be symmetrical and those peaks should be enough sharp. Okay, symmetrical and sharp peaks should be there. Symmetric means when you will be performing, then you will be getting kind of peaks that which is likewise straight in the first position. Then after, it may be slanting. Okay, but those kind of peaks will not be are not recommended. It is not acceptable. Having peaks which is symmetrical, which is and having sharpness in them. So we need symmetrical as well as sharp peak. Okay. And the fourth thing we need to achieve is as much as possible short run times. Okay? જેટલો પણ આપણો run time short હશે that is more advisable because if the run time is increasing every time we need to spend that much of time for separation as well as our mobile phase requirement will be more. Okay? Now suppose you are having one component which is eluted at 2 minutes and another is eluting or giving the response at 15 minutes. Okay? We need to make changes in the mobile phase that the component which is eluting at 15 minutes may elute at much shorter time. Okay? Otherwise, so that every time when you are having the response, the component will be eluting at 15 minutes. We need to wait for 15 minutes for separation as even the phase eluting at 15 minutes, so mobile phase consumption will be more. So your method will be more costlier if the mobile phase is more consuming. So there's four things we need to achieve when we are setting any of the chromatographic method. Okay? First of all the analytes should be separable. All the peaks should be properly separated from each other, and the peak which we are getting should be symmetric, as sharp, and the run time should be short. Okay. Now these four are ideal situation. Okay. In every chromatographic run, it is not possible to get every time ideal result. Okay. So whenever we are making a chromatographic separation, we need to we should try to achieve as much as possible from this four. Okay, is it clear? Are you getting what
Yes, ma'am.
I want to say?
Yes, ma'am.
Okay, so on. These are the results which we are aiming to achieve through the chromatographic separations. Okay. Now for today's lecture, I will be further discussing about different kind of chromatographic like column chromatography, paper chromatography, uh, size exclusion chromatography, supercritical fluid chromatography. That are the different kind of chromatographic techniques used, which are the different modes of chromatography. Okay, so most of the chromatography is performed in the column. Okay? Here in the figure, you can see a diagram of packed column. Okay? Even we can prepare a basic column in our laboratory also through use of some glass wool or through use of sand and all. Okay? So we can achieve separation from that. Okay? So column we yes packed column. Yeah. In GC there are different kind of column, different kind of packed column, open bore, liquid coated. Okay. So from the top of that column we will be adding mobile. Okay, and it will be moving through the stationary phase and finally it will be detected through the detector. Okay, after elution. So modes of chromatography. Okay. Now, whenever we are performing chromatographic separation, okay, chromatography separation might not be achieved through the same interaction. There will be different kind of interaction between analytes and stationary phase. Okay. Okay. Now there will be liquid solid chromatography when the stationary phase is solid. For example, calcium carbonate or the calcium carbonate was not widely used nowadays. Instead of that, we are using silica or alumina as a solid in stationary phase. Secondly, there might be liquid and gas chromatography, in which stationary phase is low quality liquid. It should be laced volatile. Otherwise, what will be happen? Then that liquid may evaporate from stationary phase, and you need to pour it again. So liquid will be coated on support, solid support. That solid support can be, for example, Carbovex 20M, okay, which is a polyethylene glycol with a molecular mass of about 20,000 grams per mole. Okay, so there will be gas liquid chromatography. Then after liquid chromatography, in which stationary phase is liquid. Okay. Say for example, C18 silan, which is covalently bonded with inner silica support. Okay. Now, there will be movement between stationary phase and mobile phase. Your analyte will be moving between mobile phase and stationary phase. Okay. We will be discussing the points like number of plates, how the mobile phase and stationary phase partition is occurring, what the parameters will be affecting this partition in next lecture. Okay, so there will be movement between stationary phase and mobile phase. Okay, your analyte will be moving from stationary phase to mobile phase and vice versa. It may further move from mobile phase to the modes of chromatography like adsorption mode, partition mode, bonded phase mode, ion exchange, affinity, size exclusion. These are the different kind of modes which is used into chromatography. Okay. These modes will be described in which way analytes are interacting with stationary phase. Okay. Adsorption, partition, bonded, ion exchange, affinity, size exclusion. You can assume through its name also that which kind of principle or separation is there. Principles are there for separation of analytes. Okay, now first of all, we will be going to the adsorption mode, adsorption chromatography. Okay, now in adsorption chromatography, can any one of you tell me which kind of solid support will be used? You slides, we have gone through that solids. Stationary phase will might be solid, finally divided solid. Am I audible?
Yes, ma'am.
Okay. વચ્ચે બ્રેક થઈ ગયેલો હતો.
Yes, ma'am.
કે સિમરન પટેલ, પાર્થ પટેલ, માનસી પટેલ, સિમરન પટેલ.
Yes, ma'am.
Okay. Any doubt or any confusion?
No, ma'am.
Parth Patel. Okay, from adsorption, I think the connection has been lost. Okay, fine. Okay, your mic is not working, but okay. Apart from them, Krishna, Kapila, Divya, Dhruvi, Devanshi, Damini. Do you have any problem or any question?
No, ma'am.
No, ma'am.
Okay, okay, fine. Okay, so I am continuing further. Okay, is the presentation visible now?
No, ma'am. No, ma'am.
Is it so? Is it now?
Yes, ma'am.
Yes, ma'am.
Okay, fine. Okay, so adsorption chromatography. Okay, so those components which is taking much longer time to elute out, we can use some strong solvents to elute out them. Okay, strong solvent. Meaning of that is we can use more polar solvent to elute out more polar molecule which is retained for longer time on the stationary phase. Okay. Application of adsorption chromatography is that we can separate relatively non-polar water insoluble compounds. We can go with separation of isomers also. We can go with the purification of antibody fragments also through the adsorption chromatography. Okay. Now, moving ahead, the next one is partition chromatography. Okay. In partition chromatography, the solid support which should be having high surface area. Okay. The requirement which is highlighted here is solid support will be used, but that solid support need to be having high surface area. Okay. In case my screen is not visible or presentation is not changing and you are not getting, it is not visible that what I am saying, then and the presented on the slide, let me know because I might not be able to know that if there is any problem. Okay, okay, so in partition chromatography, solid support will be used, but that solid support need to have high surface. Okay, such as crushed fabric or sugar, which is coated with high boiling liquid, which is acting as a stationary phase. Okay, high boiling liquid means your that liquid which is coated on solid support need to be having less volatility. Okay, it should be less volatile. Then only it will be remaining for more time on solid support. Okay, suppose HPLC column. Okay, in HPLC column also we can have we will be having partition. Okay, so that solid support will be binded with some liquid or some another compounds bonded groups. Okay, and that bonded group should remain for longer time, otherwise your column will be degenerated. Okay, and it cannot be used further. Okay, so in partition chromatography your solid support should be high surface area. If it is having high surface area, it will be, it can hold more amount of stationary phase. Okay, here our this solid support which is having high surface area is not stationary phase. It is just a support material which will be holding the stationary phase, and your stationary phase will be liquid. Okay. Okay, now this step in partition chromatography, separation will be occurring because of difference in solubility of analyte. Okay, your analyte will be having different solubility in stationary phase and in mobile phase. Those analyte which is having more solubility into stationary phase, they will be retaining for more time on stationary phase, while those analytes which is having solubility in mobile phase, they will be eluting at first and they will be reaching to the detector. Okay, જેની વધારે time spent, જેની solubility વધારે હોય in stationary phase, they will be remaining for more time on your stationary phase. So their retention time will be more, they will be eluted at later time, while those analytes which is having more solubility into mobile phase, they will be leaving the stationary phase at faster rate. They will be eluted here, and the retention time will be less. Okay. Now, the partition coefficient we are can be defined as the partition concentration in the of analyte in stationary phase and concentration in the mobile phase. Okay, so according to that, your analyte separated in partition chromatography. Okay. Now, partition chromatography has two types. Okay. Partition chromatography is generally used into GC and HPLC. That is the separation mode in GC and HPLC is partition. In GC, if there is gas liquid chromatography, then there will be partition. But if it is gas solid chromatography, that will be adsorption phenomena. Okay. Here in HPLC, there will be partition phenomena. Okay. So that partition phenomena might be normal phase or it might be reverse phase. Okay. Okay. Reverse phase and normal phase, that is the very important thing in the HPLC. Okay. So stationary phase, normal phase. Your stationary phase is polar. Okay, you have to remember just one thing, that in normal phase, your stationary phase is polar. Okay. Say for example, there will be a cyno group or which is attached with your stationary phase. There will be bonding of that group, or your support will be modified, and the cyno group, when it is attached, your stationary phase will become polar. And in normal phase chromatography, your mobile phase will be non-polar. For example, petroleum ether or hexane. Okay, that will be used as a mobile phase into normal phase partition chromatography. Okay. While in reverse phase chromatography or reverse phase partition chromatography, your mobile phase will be comparatively polar compared to stationary phase. Okay. Your mobile phase will be polar, and for example, the polar mobile phases are methanol, water, acetonitrile. Okay, that can be used as a mobile phase. While the stationary phase, which is used into reverse phase chromatography, is non-polar. Say for example, C18 bonded phase or C8 bond phase. Okay. Okay, now because of versatility and wide range of applicability, reverse phase chromatography is most frequently used in HPLC. Okay. Mobile phase is polar, and our many of the liquids are polar, and even because water is also polar, we are using reverse phase chromatography. Okay. And for analyte which can be soluble, which is soluble into your this kind of mobile phase, it will be eluted out to the your HPLC system. Okay, so in HPLC, reverse phase chromatography is most commonly, most frequently used. Okay. If we talk about application of partition chromatography, okay, there are number of application is possible through the partition chromatography. Okay? We can go with determination of water quality, separation of aromatic molecules, yeah. Pesticide residues which is present into any kind of preparations. We can determine the pesticides also. We can go with pharmaceutical quality control test through the partition chromatography, which we are performing generally. Okay, in pharmaceuticals, we are doing the quality control test to partition chromatography. We can go with the identification and measurement of petroleum fractions through partition chromatography. Okay, so these are the few application of partition chromatography. And even apart from this listed application, there are many more advantages and use of partition chromatography. Okay, next will be the bonded phase chromatography. Okay, I'm giving you a break of 5 minutes. Okay, we will be further continuing after 5 minutes with our lecture. Okay? You can take a short break of 5 minutes, and we will be continuing further. Okay, the link will be the same, and we will be continuing with this same link. Okay, all of you got this? We will be meeting again within 5 minutes. The meeting link will be the same. Okay, so is the screen now visible again? Is my screen visible? Okay, so is the screen visible? Let me know, please.
Yes, ma'am.
Okay, fine. Thank you. Okay, so we have gone through chromatography. Okay, solid support will be there. It should be having high surface area. Okay, it will be coated through a liquid which need having high boiling point. It should be less volatile. Okay, normal and reverse. Only used in chromatography, HPLC. When the normal phase chromatography is also there. If you search for few articles of normal phase chromatography, you will be getting means normal phase is also usable, but most commonly used is reverse phase chromatography. Okay. Now, next one is bonded phase chromatography. Okay, we can consider this as some modification of partition and adsorption chromatography, bonded phase chromatography. Okay. In bonded phase chromatography, your stationary phase will be chemically bonded uh, through means some functional group will be chemically bonded on your stationary. So likewise, in example here, your silica group, SiOH group, silicon hydroxyl group will be binded with some molecule R molecule. Okay, like in reverse, R group can be C18 alkane chain or even C8 column, or even we can bind it with amine or cyano group also. Okay. Some other groups will be used also Okay, that will depend on which kind of analytes we need to separate. If we, for different kind of analytes, we can use different kind of bonded phase. Okay, the most commonly used bonded phases are C8. Okay, in reverse phase chromatography, we are using C8 and C18 alkyne chain. Okay, okay. The nature of that R means bonded group will determine which kind of analyte need to be separated. Okay. Now for to bonded phase chromatography, the theories can be of partition or adsorption. Okay, both will be describing the mode of okay, here in this figure, okay, here in this, first of all, in this equation, we can see that silicon hydroxyl group is being bonded with R, okay, through chemical reaction, and we will be getting this bonding, which will be further used separation of analytes. Okay, likewise, here the simple diagram is shown that your support material will be bonded with of the functional group R groups, which further will be used for separation. Okay. Now, after bonded phase chromatography, next one is ion exchange chromatography. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, ion exchange chromatography is the next one. Okay, its name itself suggests ion exchange. Okay, there will be exchange of anions with anion and exchange of cation with cation. Okay, ion exchange chromatography is really used for normal, like very common separations like water purification. Okay, deionization, which we are we are having. Most of all us having RO filters for what it is doing, that separation or exchange of ions will be there. Okay, okay. Now, how these ions are exchanged? Okay, okay. Ions which is having high affinity with low affinity at the stationary phase. Okay, okay. Now in this figure we can see, okay, here in the ground you can see this is stationary phase. Okay, that stationary phase will be having some bonded anions or cations. Okay, when you samples, that counter anion will be binding. Suppose if your stationary phase here, as it is shown in figure, your stationary phase is having positive ions. Okay, cations it is having. When we will be adding some sample which is having negative anions, it will be binding with the positive or and cations of stationary phase, and it will remain bonded here. Okay. Now, how this bonded anions will be released further? Okay, so there will be elution, different kind of elution techniques which is used into ion exchange chromatography. Through those elution technique, we can separate out or we can release this bonded anions. Okay. Okay. So here mobile phase anions, which has near cations, okay, which is attached to stationary phase. Anion exchange resin is this one, okay, on which anion can only attract it towards that, cation cannot be attracted because it is bonded with cations. Okay. Now here the sentence is written: ions with higher lower affinity. Okay, steady phase na the lower affinity wala ions that will be displaced with higher bonded some anions here. Okay, now we want to elute out them. How we can elute out? Through change of affinity. Will be increased with charged increases. Okay, suppose one is Na plus. You see that is single. There is Ca 2 plus 2, then the charge is increases. So compared to Na plus Ca plus 2 will be having more affinity. Okay, so as the charge is increasing, affinity will be increasing. As the size of ion is increasing, different cations and anions is having different sizes, so that they will be more solidized. So as the size of ions is increasing, like iodine, bromine, iodine, they will be having different polarity because they, and their size is also different. Okay, so as the size of ion is decreasing, affinity will be increasing. Okay, and affinity will be increasing, polarizability will be as the polarizability is increasing. Okay, so ultimately we can say that affinity is increasing as the charge and polarizability is increasing, but affinity will be decreasing as the size is increasing. Size will be decreasing. If the size is decreasing, affinity will be increasing. Okay, so in ion exchange chromatography, the stationary phase generally used are resins or gels, okay, which that carries ion exchange surface. Resins and gels are generally used, and both are amorphous. Okay, amorphous means it is not having a specific structure. Okay, so both are amorphous particles of organic material, but gels are softer compared to resin. Okay. Okay. Now the examples of both are given here. Okay. For resin, polystyrene resin is generally used, which is made through the copolymerization of styrene and vinyl bearing molecules. Okay. Here in this figure also poly sorry that polyacrylate gel is shown. Okay. Cellulose or dextran gels are used. Dextran, which is cross-linked to glycerine, we call as Cepadex, which is most commonly used gel into ion exchange chromatography. Okay. Okay. Now, as we can see in this that there is cross-linking between polymer chains. Okay, this one is the first chain, which is cross-linked to this chain through this polymerization. Okay, so this one is polyacrylamide gel, which is used into ion exchange chromatography. Okay, now, generally in ion exchange chromatography, the benzene ring of any support, okay, benzene ring of any support can be modified to produce cation exchange resin, which is having sulfonate group, or anion exchange resin, which is having ammonium. Okay, in this figure we can see this is sulfonate polystyrene cation exchange resin. Okay, this is one of that one of polymeric chain is cross-linked with other polymeric chain, and the modification is done at okay, to benzene ring. These two polymer chains are attached with each other. Okay. Now, in cation exchange resin, there can be a sulfonated group, and in anion exchange resin, there can be ammonia. Okay. Ion exchangers, whether it is cation exchange resin or anion exchange resin, they will be classified into strongly or weakly acidic or basic. Okay, means we can say that if there is anion exchange resin, it will be strong anion exchange resin or weak anion exchange. And if we say about cation exchange resin, there will be strong as well as weak cation resin. Okay, we will be going to the examples of strong and weak cation and anion exchange resin. If there is SO3 minus group, okay, present, that will be a strong ion exchanger, because this SO3 group is remaining ionized even in presence of very strong acidic solution. But if there is COO minus group, present in your ion exchanger, then it will be a weak ion exchanger because it becomes protonated at even pH of 4. Okay, so it will be losing its ion exchange capacity. So SO3 minus is a strong cation exchanger, while SCO3 minus is weak one. Okay. If we say about strongly basic quaternary ammonium salt, it remains cationic at the pH of all pH values, while if there is a tertiary anion exchanger, weakly basic tertiary anion exchanger, it will be protonated in moderately basic solution also. So it will be losing its ability to bind anions. Okay. So SO3 minus is a strong cation exchanger, while CO2 minus is a weak cation exchanger, while quaternary ammonium salt is a strong anion exchanger, while tertiary anions are weak anion exchange. Okay. Okay. Now the resins. Okay. In ion exchange chromatography, gels or resins are used as a stationary phase. Okay. And in resin, as we have seen here, that resins will be cross-linked with each other. Okay. If that resin is more cross-linked, it will become more rigid and porous. If the cross, it will become more rigid and porous as the cross-linking is. Lightly cross-linked resins is permitting rapid equilibrium of fluid, and inside as well as outside of particle. But if it is lightly, very much lightly cross-linked, it will swell in presence of water. So the ion exchange site density will be decreasing. Okay, so we should have optimum cross-link. Okay. Ultimately, I want to say that the resins which we are using for separation into ion exchange chromatography, it should be adequately cross-linked. If it is lightly cross-linked, it will be easy permit the equilibrium of solute between the equilibrium of solute. But if it will get swell and the site which is present for ion exchange, its density will be decreasing. But if that resin is more cross-linked, okay, વધારે cross-linking થઈ ગયું હોય, in that case, the resin will become more rigid as well as more porous. Okay. Okay. Now cellulose and dextran, which are polymer of glucose, is having more pore size and lower charge density than polystyrene resin. Okay, so because of that, they are more suited for large molecules like proteins. Okay, so protein separations કરવાનું હોય ત્યારે dextrose or dextran or cellulose polymers, use કરવામાં આવે છે. Okay, so here in the first part of this figure is strongly acidic sulfonated polystyrene cation exchange resin. SO3 is a minor negative ion, so it will be exchanging cations. So in a cation exchange resin. If there is SO3 group, that is a strong cation exchanger. But instead of this SO3, if there is COO minus group is present, if there is COO minus group, then this polymer will be weak cation exchange. Okay. Similarly, here in the next part of figure is a strong basic quaternary amine anion exchange resin. Okay. Nr2 plus a quaternary ammonium anion, then it will be a strong anion exchange resin. Instead of that, if there is tertiary one, okay, this is quaternary, instead of that there is tertiary group, then that will be a weak anion exchange resin. Here some few examples of ion exchange resin is given. What is there, for which kind of ions that is used. Its thermal stability is also written here. Okay, so suppose this is strongly acidic cation exchange resin. So if it is a strongly cation exchange, it will be having sulfonic acid group as SO3 minus group, okay, which will be attached to styrene and divinyl benzene copolymer. Okay, so it's matlab, this is its name, company names. Okay, if this company is making, its name is Ambrelite IR. Okay, so from this name it is available into market. It is selective for AG plus, RB plus, CS plus, K plus. Here the selectivity is also described. If there is AG present, it is more selective. Means if with SO3, if there is two mixture of this cations are present, this Ag plus will be bonded first. Okay, then after next selectivity is with rubidium, cesium, potassium, NH4 plus, Na plus, H plus, Li minus group, Zn plus 2, Cu2 plus, Ni2 plus, CO2 plus. So different cations will be there selectively binding to this and exchange reactions. Okay. Thermal stability is up to for up to 150 degrees centigrade, means it can withstand up to 150 degrees. If there is weakly acidic cation exchanger, it will be having carboxylic acid group, which is binded with acrylic, or divinyl benzene copolymer. Okay. So it is selective for this cations and good up to withstand up to 100 degrees centigrade. If there is strongly basic anion exchange, okay, it will be having quaternary ammonium group, quaternary ammonium and CH3 groups. Okay, it is selective for these ions. Okay. If there is OH minus form, it can withstand up to 50 degrees centigrade, and if it is Cl minus group, then it can withstand up to 150. Means if this is Cl minus group here, okay, it is with Cl minus, then it can withstand 150 degrees centigrade. Weakly basic anion exchanger is having quaternary amine. So NH2 group, okay, and it can withstand selective for this kind of ions. Next, it can limit up to 65 degrees centigrade. Okay, if it is attached with styrene and divinyl benzene copolymer, then it can withstand up to 65 degrees centigrade. Okay, so that is about ion exchange resin. Um, is it clear to all about strong, weak anion as well as cation exchange resin? Is it clear? Chandni?
Yes, ma'am.
Okay, Chandni Patel.
Yes, ma'am.
Okay, cation exchange resins are examples. Cation exchange resin. Any one of you? Cation exchange resin is? Anyone can tell me if you are knowing. Cation exchange resins are having functional group like SO3 minus and COO minus, and anion exchange resin are quaternary and tertiary amine groups. Okay. Okay, so that is about ion exchange resin. Next one is this ion exchange chromatography is used for water treatment. More commonly, it is used for water treatment. Okay, okay. We can obtain soft water as well as deionized water through ion exchange resins. Okay, is presentation visible right now? Is it?
Yes, ma'am.
Okay, so we can obtain soft water. Okay, For obtaining that soft water, we will be passing that water, our ordinary water, through cation exchange resin, which is Na plus form. Okay, it will if we pass water and if it is present, CaSO4 is present into water. So the Ca plus ion from that water will be replaced with Na plus, two atoms of Na plus, two ions of Na plus will be replaced for Ca plus 2, and SO4 minus 2 will not be affected. Okay. These cations are hardly soluble as salt, so Ca2 plus and Mg2 plus can be removed through your water. Once Na plus has been replaced with Ca plus 2, your resin will be having Ca plus instead of Na plus. So we can regenerate that resin again with use of solution of NaCl. Okay, we can again use NaCl solution, and that ion exchange resin will be regenerated. Okay, we can remove the bonded Ca plus 2, and we can instead of Ca plus 2 we will be binding Na plus. So we can obtain soft water through ion exchange chromatography. Even we can obtain deionized water also. Okay, so water will be passing through anion exchange resin, OH minus form, and cation exchange resin, which is having H plus form. Okay. If we add water, which is having CuNO3 2 compound, so Ca2 plus will be replaced with H plus ion, and NO3 minus will be replaced with OH minus, and your ions will be means this H and OH minus will be eluted as water, and your compound which was present into water CuNO3 2 will be trapped there. Okay, so we can obtain deionized water also through ion exchange chromatography. Okay, now when I have started this ion exchange chromatography, and I have told that illusion into ion exchange chromatography is very much important. So generally gradient illusion is used. Okay, okay, illusion is nothing but removal of analytes. Okay, illusion means removal of analyte. So gradient, okay, illusion is having two types: illusion, gradient illusion, and isocritic illusion. Okay, in isocritic illusion there will be fixed composition of mobile phase. Okay, your mobile phase will be fixed. Suppose your mobile phase composition is of water and methanol in ratio of 50-50 throughout the chromatographic run. That composition of water and methanol will remain same 50-50 in isocritic illusion, while in gradient illusion that composition might be changing, will be changing. You can change the initially for 5 minutes the composition might be 50-50. After 5 minutes that composition will be 50 60-40, or even 40-60 likewise. So during chromatographic run, if we are changing the composition of mobile phase, then it will be called as gradient illusion. And if we are not changing the composition, we are remaining it constant throughout the chromatographic run, then it will be called as isocritic illusion. Okay? So in ion exchange chromatography, generally gradient illusion is used. That gradient can be either concentration gradient or pH gradient. Okay. Now in ion exchange chromatography, exchange of ions is that. Okay. So illuons, which is used in ion exchange, contains ionic compound in high concentration initially. Then after we can decrease or increase the concentration of illuent during the run. Okay. So if we are changing the concentration of your ion exchange solution, then it will be called as concentration gradient. And in pH gradient, we will be changing the pH during the during your chromatography. Okay, so in pH gradient, a fixed concentration of weak acid, suppose which is solvent A, will be mixed with increasing concentration of strong base. Okay? So pH gradient and concentration gradient both can be used, okay, for the illusion. If we talk about application of ion exchange chromatography, it can be used for separation of vitamins, separation of ionic cations and anions, obviously separation of anions and cations. If there is low molecular weight organic acids are there, they can also be separated. We can go with analysis of some serum also, and simply for analysis of drugs also. In pharmaceuticals we are going with this, okay, ion exchange. Okay, the application of ion exchange chromatography is very much wide. It is just not used in the pharmaceutical industry, it is used in the other industries also, other chemicals, as well as for softening and demineralizing household use also. This ion exchange chromatography is there. Okay, so that is about ion exchange chromatography. Next one is, uh, anyone want to ask any question about ion exchange chromatography? Anyone? Any question?
No, ma'am.
No, ma'am.
Okay. Size or molecular exclusion chromatography. Size exclusion chromatography, or other meaning is molecular exclusion. Okay. Okay. So its name suggests as there will be separation of mixture according to different molecular size of components. Okay. The figure is shown here. Okay, there is a column shown here. Different portions are there. Okay. In the initial portion, there is very small particles. In middle one, there is medium size particles, and last one is a bigger one size. So in size exclusion chromatography, you have to understand properly that this thing is enlarged here, this middle thing is enlarged here, medium particle, and last one is enlarged. Okay. Okay. Now, if your mixture, which you need to separate, is having very small molecules. Okay, if it is having very small molecules, it can intrude even inside the particles of your stationary. Okay, it can introduce into inside of your particles of stationary phase. If it is medium one, it may not penetrate into pores of your particles, but it may pass through the space between different particles which is packed into form. But if it is very large particles, okay, it will not even pass in between the particles. It will be moving. It will not enter the pores, and it will be very restricting, and it will pass between the gaps of particles. Okay, so it will not entering into the pores of your uh, pores of the molecule or pores of the particles, which is used for packing of form. So in size exclusion chromatography, there is no chemical interaction with the mobile phase or stationary phase. Okay. There will be only physical interaction between the stationary phase and your analyte. Okay, if your molecule or analyte is having very small particle size, then it will be entering into the pores of your packaging material, okay, and it will be remaining for more time into stationary phase. But if it is very large size, it will be taking less time to dilute out. Okay, so in size exclusion chromatography, the bigger particle will be moving at first. Very bigger particle will be moving first because it is not included into the spaces of or pores of your stationary phase and it will be not retaining at all and it will be eluting at first. Okay. Smaller particles will be taking much time because it will be following much longer time or following much longer way, so it will be eluted at the last. Okay. Okay, now the stationary phase which is used into size exclusion chromatography is a silica gel which is having white fluid size, polysaccharides, synthetic polymers, for example, polyphenide or styrene divinyl benzene copolymer. This can be used as a stationary phase. The stationary phase pore size may vary in the range of 4 to 250 nanometer. Different pore sizes are there. We can use stationary phase with different pore size according to our application. अपनी analyzing particle size से इन according we can select different kind of stationary phase. Okay. Now, size exclusion chromatography can be further divided into two kinds. Okay. Size exclusion chromatography can be termed as molecular chromatography or gel chromatography also, gel filtration chromatography or gel permission chromatography. The difference between gel filtration and gel permission chromatography is that if your mobile phase is aqueous, if you are using mobile phase which is having aqueous component, then that technique will be called as gel filtration chromatography, GFC, SCC, gel filtration size exclusion chromatography. And in this case, stationary phase will be hydrophilic. Okay? It will be hydrophilic means water level. Okay, so if your mobile phase is aqueous, then your stationary phase will be hydrophilic, then that kind of size exclusion chromatography will be called as gel filtration chromatography. But if your mobile phase is organic, if it is organic, then your chromatography will be called as gel permission chromatography, and your stationary phase will be water heating, means hydrophobic. Okay, so size exclusion chromatography is gel filtration or gel permission. If your mobile phase is having aqueous component, it will be called as gel filtration chromatography. And if your mobile phase is organic in nature, it will be called as gel permission. Now there is some theory or chromatographic parameters behind size exclusion chromatography. There is an equation Vt, okay, is equal to Vg plus Vi plus V0. Vt is a volume, total column volume. Okay. Vt is total column volume. Okay, as I have shown here in the figure, this is this column volume will be Vt. Okay, so Vt means total volume of your column, while Vg here, the second term is Vg, that is the volume which is occupied by the solid matrix. Solid matrix occupied volume is Vg. While this Vi and V0, Vi is volume of solvent held in the pores. Okay? Vi is volume of solvent which is held in the pores of your particles. Okay? And V0 is a free volume outside the particles. Okay? Vi is equal to Vg plus Vi plus V0. Vt means total volume. Vg is the volume of packing. Okay, આપણે જે કોલમમાં પેક કરેલું હોય that volume is Vg. Vi is volume of solvent, while V0 is the free volume outside the particles. Okay. Okay, now there will be two cases. Okay. This term Vt is equal to Vg plus V0 or Vt is equal to Vg plus V0 plus Vi. Okay, now when V0 will be there, if there is no mixing of diffusion is occurring. Okay. If your particles are very much large and it is not penetrating inside the pores, so V0 will be is the volume of solvent which is needed to transport the components to the whole column. So because your particles are very much large and it cannot enter the holes, then it will be V0. And V0 plus Vi will be that if the volume of solvent is needed to transport the component which is small and it is entering inside the holes. If your analyzed particles are small and if it is entering inside the holes of your support material, we need solvents which need for transporting those molecules, then it will be V0 plus Vi. And if it is very much large and it is not entering inside the pores, there will be V0. Okay, ultimately we can write elution volume VE. Okay, VE is elution volume, matlab how much amount of mobile phase we need to elute out any of the analyte is VE. Okay, VE is equal to V0 plus KVI. Okay, is the elution volume, the volume of mobile phase that is required for elution of compound. And at the constant flow rate, it will be proportional to retention time. Okay? At the constant flow rate, it will be proportional to retention time. Okay, V is equal to V0 plus KVI, where K will be a constant and it will depend on different kind of flow rate or mobile phase. Okay, so that is chromatographic parameters in HCE. If we think about application of size exclusion chromatography, it is used for determination of molecular mass of synthetic volumeter. It is used for analysis of some sugar, analysis and isolation of liquid polymers can be done through size exclusion chromatography. This can be used for purification, identification as well as quantification of protein mixtures. This can be used for study of polymer reaction kinetics. We can go with purification of large biomolecules also, which having molecular mass more than 10,000 grams per mole. Okay, so ultimately in SARS exclusion chromatography, we can separate and analyze the components according to their different sizes. So this is about size exclusion chromatography. Okay. We will be revising the thing in little bit faster way, which what we have done today. Anyone want to ask anything about size exclusion chromatography? Anyone? Anyone? Am I audible?
Yes, ma'am.
No, ma'am.
Okay, no question. Okay, so today we have gone through some basics of chromatography. Okay, like stationary phase is there, mobile phase is there. Okay, fixed one is a stationary phase, moving one is mobile phase. Okay, then after according to affinity and solubility of components, they will be moving through the stationary phase on addition of mobile phase, and they will be eluting at different rate. The graph of detector signal versus time will be called as chromatogram. Okay, uh, the different kind of chromatography come into existence on different years. Almost 100 years is there upon existence of chromatography. Okay, the analytes will be interacting it in different ways through stationary phase and mobile phase. According to them, they can be separated out. When we are going to analyze any component through chromatography, we need to aim on four things: that all the analytes need to be separated, there should be well separated peaks. Those peaks should be sharp enough as well as symmetrical, and the run times need to be shorter. Okay, the run time as much as short we need to keep. Okay. Then after we have gone through different kind of modes of chromatography, we have gone through adsorption, partition, bonded phase, and annexation chromatography. In adsorption chromatography, the stationary phase will be finely divided solid with which is having high surface area. Okay, and there will be interaction of analytes on those stationary phase through adsorption phenomena. Okay. For elution, we can use mobile phase, which is having more affinity towards stationary phase compared to your analytes. Okay. If your mobile phase is much strong solvent, then the retention time will be shorter one. Okay. Mobile phase component will be competing with the stationary phase, competing with the analyte molecule for attachment into on the stationary phase. Okay, different applications of adsorption chromatography. Then after we have gone through partition chromatography, in which there will be solid support, which is holding your stationary phase. Your stationary phase will be less volatile liquid. Yeah. According to solubility of analytes, different analytes will be having different solubility into stationary and mobile phase. They will be eluted at different time. There is normal and reverse phase in the partition chromatography. If your stationary phase is polar and mobile phase is non-polar, it will be called as normal phase chromatography. And if your mobile phase is polar while stationary phase is non-polar, that kind of chromatography will be called as reverse phase. Because of versatility and more applicability, reverse phase chromatography is more widely used. And after we have gone through bonded phase chromatography, different bonded groups are attached with stationary phase on solid support. That can be C8, C18, cyno or amine groups, which is bonded on your solid support. So that will be bonded phase chromatography. Ion exchange chromatography is that in which different anions are exchanged with anions while cations are exchanged with cations. Okay. Ions with higher affinity will be displacing those ions with lower affinity, and affinity will be increasing with charge and polarity, but it will be decreasing with increase of size of ions. Okay, if your size of ions are decreasing, affinity will be increasing. Resins or gels are used as a stationary phase into ion exchange chromatography. There will be polystyrene resin and cellulose or dextran gel, which is more common used in ion exchange chromatography. There will be strong cation exchangers, weak cation exchangers, strong anion exchangers, and weak anion exchanger. If there is SO3 minus group, that it will be strong cation exchanger, and if it is COO minus, it will be weak cation exchanger. Okay. If there is quaternary ammonium group, it will be strong anion exchanger, and if it is there is tertiary group, there it will be weak anion exchanger. Okay. The cross-linking of resin should be optimum. It is more cross-linked, then it will become more rigid and porous. And if it is very less cross-linked, there will be swelling through water, and annexion size will be decreased. Density of that will be decreased. Okay. This we have gone through few examples of resins. Connection chromatography used for obtaining soft water as well as for deionization of water. Connection chromatography is used. Elution in ion exchange chromatography is done through gradient elution by changing the composition throughout the during even the chromatographic run. Okay, there can be concentration gradient or pH gradient. And after we have gone through size exclusion chromatography, in size exclusion chromatography, there is no chemical interaction between mobile phase and analyte or analyte and stationary phase. Only physical interactions are there. There is gel filtration and gel permission chromatography. If your mobile phase is aqueous, it will be called as gel filtration, and if it is organic mobile phase, it will be called as gel permission chromatography. Okay. We have gone through this equation for size exclusion chromatography. Vt is equal to Vg plus Pi plus V0. Vt is total column volume. Vg is volume occupied by packing material, solid matrix. Vi is the volume which is of solvent, and V0 is free volume. Elution volume will depend on flow rate proportional to its tension time. So Vt is equal to V0 plus KVI. Okay, and we have gone through the application of size exclusion chromatography. We will be continuing with supercritical fluid chromatography in our next lecture of basic chromatography. At this point, if anyone has any questions, still they can ask. Okay, if you have any doubt or any problem, you can ask me or here only at this time, or you can personally contact me as my number is there in our WhatsApp group. If you have any query or any doubt or any confusion, you can ask me at any time. Anything you want to ask? Arun, Patel, Chandni, Damini, Devanshi,
No, ma'am.
Divya,
No, ma'am.
Devanshi,
No, ma'am.
Divya, Divya Jadhav,
No, ma'am.
Kapila, Krishna, Krishna
No,
Raj,
ma'am.
Lalit,
No, ma'am. No, ma'am.
Lalita,
No, ma'am.
Mansi,
No, ma'am.
Nanima, Hina, Hina, Parth
No,
Patel.
ma'am.
Okay, your mic is not working. Okay, Pooja and Simran.
No, ma'am.
Okay, my speed is adjustable to all of you. Am I talking in a faster way or it is understandable? Is it okay with you, no?
Yes, ma'am.
Okay, so we are ending for today's lecture. Okay, and we will be meeting in the next schedule of our basic chromatography. Okay, all of you can leave now.
Thank you, ma'am.